Hello everyone, a very good afternoon to one and all. My name is Srinivas and I am from BYJU'S Exam Prep. I'm here to talk about the maths section of CUET and not just talk, as I discussed in the session of mine day before yesterday. If you would have attended it, I have mentioned that I'm going to take up a series of topics within maths. So this is the first class of the maths topic. I have a bunch of them coming over the next 1 week or 2 weeks. In fact, these sessions ideally will be at 1 p.m. on Thursdays and Fridays, I believe. So please be tuned, subscribe to the channel if you have not already subscribed into our YouTube channel. These sessions will be updated on the channel. If you have already clicked the notification icon, you will be getting these notifications. So friends, today being the first session, we're going to take up one of the very, very important topics in maths. That is the quantitative part called basic ratios, proportionality, and the topic related to ratios, which is time and work and time and distance. So your ratios, so that these three are actually kind of related. So your basic ratios, then your time and work, time, speed and distance, and time and work. These are kind of related, and if you have seen my session some time back, you would notice that these basically occupy almost about 50 to 60% of your questions. So we all know by now that there are totally going to be 15 questions in maths. I expect at least the entire arithmetic put together will be at least 8 questions is my expectation. Out of these 8 questions, you can definitely expect around 4 to 5 from this particular area what we're going to discuss today. So if you follow this session of mine today carefully for the next 1 hour, I'm kind of, I'm pretty sure, pretty certain that you will be able to attempt 4 to 5 questions out of your entire 15 questions in maths. Okay, so let's go ahead and take a look at the topic per se. Dhairya Shah. Dhairya, the concept does not depend upon the exam. So this is basically for CUET, but again, when I say time and work, time and distance, the concept remains the same for whichever exam you're looking at. So I will not say this is particularly for IP Mat or particularly for CUET only, because I cannot say this is only useful in this exam, right? The concepts remain the same. Right, so let's go ahead. Now in this, I'm not going to give you too much of theory. I'm assuming that the basic theory is known, but what I'm going to give you is a lot of practice. So I have about 12 or 15 questions to be given to you as practice. So every question, I'll give you a certain amount of time. And after the time finishes, I will explain the solution to you. And I will also explain if there is any theory that I want to explain there. As taking that question as an example, I'm going to do that. So I hope all of you have a pen and a bunch of papers beside you. So let's start off with the first question coming your way. All right. So here's the first question, my friends. Try to do this question. It's a very, very simple question. You should ideally be able to do it in 60 seconds. After 60 seconds, I will give you the solution, explain the basic idea behind the question also, and that's how the journey is going to be for today's session. So please start answering this. Guys, is the screen clear to all of you? Is anybody else unable to see the screen clearly? Or is it only an issue of Nidhi Dubey? Because I remember last session also, Nidhi, you were saying the same, that the screen is not clear. Whereas there was nobody else who was complaining about this. So Dhairya Shah, can you please confirm if the screen is clear? Okay, it's clear, Muskan, thank you. So Nidhi, I think the issue is from your side, my friend. Others are able to see the screen clearly. Okay, so here's what we have. So 60 seconds are up. I haven't got any answers. So let's take a look at what the question says. The salaries of Karthik and Kiran are in the ratio 21:26. So Karthik and Kiran, the ratio of salaries are 21 and 26. Their expenditures are in the ratio, expenditures for the same set of people are in the ratio 3:4. Now each person saves 2400. Remember, this 2400 is saved by both, not together but individually, which means this is 2400 and this is 2400. We all know what is saving. Your income minus expenditure is your saving. So your income, if I take 21x, then minus expenditure should be my saving, correct? Or the other way around, your 21x minus saving should be my expenditure, right? So I'm going to use this way of writing my question. So 21x minus savings, S-A-V, yeah, savings of the first person. Saving of the first person is the same 2400. Okay, divided by, I'll take the ratio of the savings of the, or the equation for the second person. Second person, Kiran. This Kiran's income is 26x and saving is again 2400. So if I take this ratio, what do I get? I get the ratio of their expenditures, because income minus expenditure is your income minus saving is your expenditure. So I am taking the ratio of actually expenditures, which is given to me as 3/4. So this is a single variable equation. Cross multiply and get your answer. So if you cross multiply, you'll get 84x minus 0, 0, 4, 4 are 16, 4 to 8, 9600 is equal to 0, 0, 4, 3 are 12, 3 to 6, 7200 and 26x. So 26 into 3, that is 75, 78, 78x. So what do I get? If I rearrange the terms, I'll get 6x is equal to 9600 minus 7200. This is basically 70, 80, 90, 2400. So my x should be 2400 by 6, which is 400. Okay, my x should be 400. So what they're asking now is find the salary of Karthik. Karthik is 21x. So into 21 is what I want, which is 8400. So that is going to be option A. So here we are dealing with ratios, but if you try to take income and expenditure separately, like if you take income as 21x and 26x and expenditure as 3y and 4y, you will still get, because the subtraction should give you 2400 and here you should be getting 2400, but it's going to become a little bit more lengthy. So but the better way is convert your ratio in the as a ratio of your expenditures. That's directly given, so that will be faster. Okay. Okay, so I have few comments coming across. Surya Malik is saying, sir, applied maths. Can you just take the chart to a little bit of right? I want to see the, so the right side screen, can you just take it to a little bit more to the right? Okay, sir, applied maths questions are also included in this only. Yes, Surya, applied maths actually will not be too much of, applied maths is different, guys. The thing about applied maths is that is your domain specific question. Okay, so don't worry about applied maths. I don't think there'll be applied maths questions as a part of your general test. General test, we are restricting ourselves to basic arithmetic, basic algebra, basic geometry and mensurations. Okay. Right, so this is your first question. I hope you understood. It's just a warm up. I'm sure you will be getting the further questions. Question number 2. This is your question. Please try to do this in 60 seconds now. Very good, Tarun. That's the first answer and the correct answer. Very good. So let's take a look at it. 60 seconds are more or less up. So the question says the runs scored by Suresh and Ramesh. So Suresh and Ramesh, this ratio is 5:6. And the run scored by Ramesh and Naresh. So if I put Naresh here, Ramesh and Naresh is 2:5. And they're saying that the total run scored by all of them is 156. Now we know what to do if we have a continuous ratio, but we have these two people and these two people now. I don't have a continuous ratio, so the logic is very simple. Can I combine all these three together? And there's a very simple way of combining them. Look at which person is the link. The first pair and the second pair, the link is this person Ramesh. So try to make the Ramesh ratio value same for both. So ideally, if this is 6, try to make this also as 6. So this you should multiply it by 3. So what do you get? 5:6. This 2 into 3 is 6. So the 6 is already written, and 5 into 3 becomes 15. So the ratio of the three people is Suresh, Ramesh and Naresh is 5:6:15, and we can take the actual values as 5x, 6x and 15x. So the total of all of this should be 156. So this gives you 26x equal to 156, or x is 156 by 26. Okay, so 26 6 I think 6 6 36, 6 2 12, yes, this goes 6 times. So what are they asking? They are asking find the run scored by Ramesh. Ramesh is 6, so 6x. So 6 into 6 is 36. That is your answer, option number B. So Tarun, Sneha and Rahul, all three have given the correct answers. Guys, very good. You need to just increase your speed a little bit, because in a question like this, taking more than 60 seconds means you are not either thorough with the concept or you are not fast in your calculations. So 60 seconds is the ideal time. Anything more than that is bad. Okay, so improve your speed a little bit. Next question, moving on. Good, this is a nice simple one again, 60 seconds. Your time starts now. Try this out. Very good, Tarun, you have given the answer in about 30-35 seconds. Muskan, good, under 60 seconds you have given. Rahul, just about 60 seconds you have given. Great, guys, all three are the correct answers. Happens to be option D. So let's see why is the answer option D. So the average of 30 students in a class 10th is 16 years. So 30 students, the average is 16 years. And another 20 students, here the average is 14 years. Okay, so they're asking you, if you combine them, what is the average? This is a typical case of weighted average. What is the meaning of weighted average? When you're mixing two different things, the final average will be A1 W1 plus A2 W2 and so on, divided by W1 plus W2 plus and so on. This is basically the formula for your weighted average. I'm sure you know this. If you do not know, please understand what is the meaning here. A1 is the average of the first group, W1 is the quantity of the first group, A2 is the average of the second group, W2 is the quantity of the second group, and how many ever groups they are, you multiply all of them like this and divide by the sum of all the number of items. So you basically, if you apply this, you will get 30 into 16 plus 20 into 14 divided by 50, because 30 plus 20 is 50. So you can cancel out the zeros, so you'll get this as 48 plus 24 by 5, sorry, 28 by 5. So 60, 68, 76 by 5. So this gives you 5 ones are 5, 6, 7, 25, 5 5s are 25.2, which is option number D. Okay, so the concept of weighted average will be used when multiple mixtures are getting put together. Right, so you are basically saying that this itself is a mixture. 30 people themselves will have different average, different weights. So this average is 16. That's your first mixture. Then you have another 20 people. Each person will have a different weight or an different year. Sorry, not weight. And this average is 14. So this is the second mixture. When you're mixing two mixtures, the concept that you use is weighted average to find the final average value. Okay, so that's your answer. Let's move on. Okay, now we are going into time and work and time and distance. So we will use the concepts of ratios over here. And here I'm going to explain to you the idea behind time and work, how I particularly solve time and work and time and distance. But right now, solve it on your own. I'll give you 60 seconds once again. It's a very simple question. 60 seconds. Your time starts now. That's great, Tarun. 15 seconds. You have given the answer. Awesome. Muskan, very good. Rahul, correct. Okay, so let's see what is happening here. This is a very straightforward question, and there's a particular reason why I've given this question. It's a dead easy question. Now we all know if A can do a piece of work in 30 days, then in one day he can do 1/30th of the work. If B can do a piece of work in 45 days, in one day he can do 1/45 amount of work. So if they are both working together in one day, you will be able to do 1/30 plus 1/45, which is you'll take the LCM of 30 and 45. What is the LCM of 30 and 45? I think it's 90. So 30 goes 3 times, 45 goes 2 times. This is 5/90. So this becomes 5 ones are 5, 5 eights are 40. So this is 1/18th. So when two people are working, you'll be able to do 1/18th of the work in one day, which means the full work will be done in 18 days, and that's your answer. Almost all of you got the correct answer. But this approach is what you're being taught in your school. There's nothing wrong with this. It's a perfectly good approach. However, I'm going to give you a slightly different approach, which will make more complex problems actually easier. Okay. By the way, once again, remember there's nothing wrong with this, but I'll give you a slightly different approach, which will make your calculations and understanding easier. So let's take the different approach using this simple example. What I do is, I will write down the A and B actual times, time actuals for A and B. So time actual is 30 and 45. Now in this approach, I will use something called as the efficiency. Okay, something called as the efficiency. Now in time and work concept, what is an efficiency? Efficiency is the rate of doing work. It is work done by time taken to do the work. So efficiency is the rate at which you can work. It is the work done divided by the time taken. And efficiency is basically inversely related. You can see this. Efficiency and time, they are inversely related to each other. So the time ratio of your time, take the ratio of your time. What is the ratio of time? So 5 goes 6 times, 5 goes 9 times, or rather 5 goes 5 twos are 5 nines are. So 3, in fact 15 goes 2 times, 15 goes 3 times. So the ratio is 2:3. Bring it to the simplest ratio. Now if time and efficiency are inversely related, then the efficiency ratio should be 3:2. So remember, inverse of 2:3 is 3:2. Now one small point about ratios. What is the inverse of 2:3? Now I write the answer directly as 3:2, but you need to understand how did I get this. I did not just reverse it. It is not reversing. Please remember, if I ask you what is the inverse of 1:2:3, it should not be 3:2:1. This is wrong. Okay, what is the meaning of inverse? Inverse meaning if A is to B, the inverse need to be found out, then the inverse is 1/A:1/B. When there are only two numbers, when you do this, it is the same as writing the reverse 3:2. But When you have three ratios, 1:2 is to 3, the inverse is 1/1 is to 1/2 is to 1/3. Now you take the LCM of 1, 2 and 3, which is 6, and you'll notice if you multiply this entire thing by 6, you will get this inverse ratio as 6:3:2, which is not same as 3:2:1. So one of the common mistakes that students make is they forget that inverse ratio, when there are 3 or more, should not just be written in the reverse order. You should inverse every number here and then find the value. Okay, so that's the idea of inverse. When there are two things, you can just reverse them. It doesn't matter. Because 1/a is to 1/b, LCM is AB. Multiply with AB, you'll get B is to A. It is same as reversing. But that is not the idea. The idea is actually 1/, and 1/. You are supposed to do it that way. Anyway, so once you understood this, then you can find the work. What is the work? Work is always, remember, efficiency is work by time. So your work is efficiency into time. So time is 30, efficiency is 3, so it is 90 units. 45 and 2, it is 90 units. So you should get the same work for both because they are doing the same quantity of work. If you did not get the same quantity when you multiply, it means somewhere something has gone wrong in your calculation. Okay, so ideally if your calculation is correct till here, you should be getting 90 and 90. Now 90 is a work that needs to be done. What is the case? The case is when both of them are working together. So when both of them are working together, the efficiencies can be added. When people are working together, the efficiencies can be added. So that is the advantage of using the efficiency concept. So it is 2 plus 3 together in one day. How many days? X number of days. So your X will be 90/5, which is 18. Now you might say that, sir, this is taking, probably 30 seconds longer because I have to create this entire small table and then do everything. Why can't I just write it as 1/30 plus 1/45 and get my answer? Because this is like 2 steps. Agreed. Now the problem comes, or rather the idea is, even if the question becomes lengthier or more complex, this distance, or rather this length, will not change. This is the only thing you need to do and write this final equation to get your answer. But when you're dealing with this 1/by idea, you're writing it in terms of 1/by the time taken plus 1/by the time taken. The complex the question is, the more difficult the equations are going to become for you. So the flip side, or rather the advantage of what we just discussed is this 3 steps or 4 steps will remain 3 and 4 forever. It will not change. Whereas this kind of idea will become more and more complex if the question becomes lengthier. Alright, so that's the advantage of what we just discussed. We'll have 3-4 more questions coming your way, and you will notice that all the questions will write only the 3 steps. We will write your time actual, from there we'll find the ratio of time. From there we'll find the inverse ratio, which is efficiency, and there you'll get your work. Once this small table is created, the next thing is, now this total quantity of work is done by whom? That's it. Let's take one more question. Take a look at this again. Try to do this in the way that I just described to you. Try to do this in 60 seconds. I'm always giving you 60 seconds because these are questions which should be done in 60 seconds max. So take a look at it. Very good, Muskan. Tarun, correct. Rahul, correct. In fact, all 3 correct answers. Awesome. So what is happening in this particular question? We are looking at A can complete a piece of work in 24 days while working alone. A and B together can complete the same work in 8 days. So if I write A, time actual taken by A is 24, whereas A plus B, the time actual is 8. Okay, so what is the ratio of times? 3:1, because ratio is 3:1, which means the efficiency should be 1:3. Once you get the efficiency, the next step is find the work. Work is always, remember, work is always actual time into efficiency ratio. So 24 into 1, so it is 24. 8 into 3 is 24. Now, basically what you understood is A plus B total efficiency is 3. Which means if I look at only B efficiency should be how much? Now remember, A is 1 and A plus B is 3. So B should be just 2. The quantity of work done by B is again 24. Right? Because when B is working alone, B will still have to do 24 units of work. Therefore, time taken will be, remember, these two, the product should be 24. So 24 by 2 will give you 12. So the same table will keep coming back to you again and again, irrespective of how the question is. That's the advantage of this particular idea. Okay, so let's go ahead. The next question coming your way. Try this again, 60 seconds. Time starts now. Okay, Tarun has given the answer option as D. Very good, Tarun. That's the correct answer. Let's take a look. This time I got only from Tarun, Rahul and Muskan have not answered. Let's see what is happening. Why is it creating an issue? So we have A alone, time actual is 16 for A and B it is 20. Okay, so the moment I get these two, first thing I'll do is I'll take the time ratios. Time ratios is 4 4s are 16, 4 5s are 20. Which means efficiency ratio will be 5:4. So therefore the work quantity will be 20 into 4, which is 80. 16 into 5 should also be 80, which means I have done my calculation correct till now. So the quantity of work is 80 units. We use the word units, 80 units. So this 80 units has to be done this time by both of them working together. However, they work together only for 8 days. So for 8 days, it is A and B together. So the efficiency becomes 5 plus 4, which is 9. After this 8 days, what happened? After 8 days, A fell sick, so only B is left. So B's efficiency is 4. So 4 times, but how many days will it take? We don't know. Let's say the number of days is D or X. Let's say the number of days is X. So this is my equation. My total work should always be equal to what is getting done. So 8 days, 9 efficiency per day, 8 9s are 72, and the remaining days only B is working. So this is 8 equal to 4x or x equal to 2 days. So basically B will work alone for the remaining 2 days to get the work done. That's your answer. Okay, so if you notice, once again we did the same thing. One small table and one equation. That's it. So how many twists and turns the question can give you? In this approach, you will finish it in one table and one equation. That's the beauty of this simple approach called unitary method. Okay? Right, let's go ahead. Amit, how did I get 80? 80 is basically the product of 16 and 5, 20 and 4. So remember, 80, basically this is your work done. Work is efficiency into time actual. So efficiency ratio into time actual. This is your work done. Okay? Let's go ahead. Next question. This is again not a very difficult one. This is quite straightforward. 60 seconds. Time starts now. Okay, 60 seconds up. I haven't got even a single answer this time. Is it that difficult? See, what is the concept here? The concept here is both of them are working for 8 days together. So when there are 2 or 3 or how many ever people working for the entire duration of the time, nobody is taking a break. All of them are working for same amount of time. In such a case, the concept is the money should be divided in the ratio of their efficiencies. Because see, if I and you are both working for 1 day, both of us are working for 1 day, I should not say that I should get same money as you. It is not equal splitting, because if I am more efficient than you, in that 1 day, I will do more work than you. Right? So how can I say that we should get, or how can you say that we should get equal money? So the money should be divided. The correct concept is money should be divided in the ratio of work done. And because time, so work done is what? Efficiency of A into time of A is the work done by A. Similarly, what is work done by B? Efficiency of B into time taken by B. This is the ratio in which the money should be divided. But if the times are same, because both are working for the same time, then ultimately it is same as dividing it in the ratio of the efficiency. That is the idea here. Now I can create a question where I can say A worked for 4 days and B worked for remaining time. Then you cannot blindly say ratio of efficiencies, because there you have to calculate how much work A will do in 4 days and the remaining quantity of work is being done by B. So the ratio of money or the money distribution should be always in the ratio of the work done. The simpler cases, when the times are same, the times get cancelled. Hence, in this particular case, ratio of work is same as the ratio of efficiencies. Okay, so we basically looking at we are looking at who is that? Suresh and Ramesh, right? So Suresh plus Ramesh take 8 days and Suresh alone will take 10 days. So these are your actual times. So what are your time ratios? Time ratios are 2 4s are 8, 2 5s are 10. So efficiency ratios are 5:4. Now remember, Suresh is 4, Suresh plus Ramesh is 5. So only Ramesh should be 1, because 4 plus 1 only gives you 5. So the ratio of efficiencies of Suresh and Ramesh are 4:1, which means this 30,000 should be divided in the ratio of 4:1. So 30,000 divided by 5 into 1 should be the amount of Ramesh. So Ramesh should be 6,000. That is your option B. Okay, that is your option B. Clear? Right, so please be careful about these kind of questions. If the time is same and everybody is working for the same quantity of time, then the ratio is same as efficiency. Otherwise, always divide it in the ratio of the work done. That is the actual concept. Right? Let's move ahead. So I think Rahul, Tarun and Muskan did get the answers, but a little bit late. Guys, you have to be, I don't know what held up your, this is actually much more easier than the previous questions, right? Only thing is you need to know how to divide it. That's all. Next question coming your way. Look at this. I will give you 2 minutes for this. Try to do this. It's not lengthy. I'm just giving you 2 minutes to think. That's all. It's not lengthy at all. So this will be 120 seconds. Your time starts now. Are you sure, Muskan? Please check once again. 90 seconds up, last half minute. Alright guys, so 2 minutes up. I haven't got any answers. Again, it looks like it's a difficult one for you, but actually it is not. Let's see what is the right approach for this to make this seemingly difficult question into an easy one. We will again take the same idea. The approach is the same. A alone can do a piece of work in 20 days. B can do a piece of work in 30 days. So time actuals are 20 and 30. So time ratios are 2:3. So efficiency ratios are 3:2. So the quantity of work to be done is the product of these. So it is 60 and 60. So the quantity of work is 60. Fine. Whoever is doing it, whatever way you do it, it has to be 60 units. Okay. Now let's take a look at what is happening. 60 is equal to, now day one, both of them are working because B works on first day whereas A is working every day. So day one, it is the total efficiency is sum of these two, which is 5, plus day 2 only only A is working. B is not working on day 2. In fact, day 2 and day 3, each day the efficiency is only A. So it is 3 plus 3. Then again day 4, A and B will work. Then day 5 and day 6, only A will work. So if you notice, every 3 days it is a repetition. First day, second day, third day. Then fourth day is same as the first day. So every 3 days, the work, the way in which the work is getting done will get repeated. So let's take a look at what happens. Total work done for every 3 days will be how much? 5 plus 3 plus 3. How much is that? 5 plus 3 is 8. 8 plus 3 is 11. So 3 days, 11 units of work will be done. Another 3 days. So, cycle. So let's call it as cycle 1. First cycle. Okay. So cycle 1, if I write it here, cycle 1, 11 units of work is done. Cycle 2, 11 units. Remember, each cycle is 3 days. Each cycle is 3 days. Cycle 3, 11. Like this, what is the nearest multiple of 11 to 60? The nearest multiple is 5 cycles because 11 5s are 55. So I need cycle 4 and cycle 5, each 11 days. So when I take 5 cycles means each cycle is 3 days. So this is 15 days. In 15 days, I will finish 55 units of work. Now, it is the 16th day, right? 15 days are over. It is the 16th day. In 16th day, who will be working? 16th day, that is 16th day. It will be the turn of A plus B together. So, when they are working together, they will work or make 5 units of work. So 5 units are getting done. So 55 plus 5, 60 completed. Full 60 is done for you. So the work is getting completed by the end of the 16th day. So you need full 16 days. That is your answer. Answer option B. Okay. Now, many of the students do this mistake of taking that you are saying that 11 units of work in 3 days. 60 units of work in how many days? So you cross multiply and say 60 into 3 by 11. This will be wrong. Because what is the meaning of this? When you took this 11 units of work in 3 days, the meaning is you are taking average everyday work as 11 by 3. But that is not the reality. The reality is it is 5, 3 and 3. So when you take 11 and 3 and you calculate for 60 units of work, you will get the wrong answer because so when it comes to the 16th day, you are doing 5 units, not 11 by 3 units. Because of that, you'll be getting a mistake. So ideally in this kind of questions, don't do this cross multiplication. What you should do is look at the nearest multiple, go till there, and from there go step by step. So if you notice, I came till the nearest multiple of 60 to 11, so 55. After that, I will take day after day. Okay, that's the idea. Right, so before we move on further, guys, if you've liked my session till now, please hit on the like button. If you like, getting more notifications about sessions like this, click on the bell icon and please do subscribe to our channel on YouTube. You will be getting a lot more information. Going forward, next question. This is a question over here. Once again, a simple one. try to do it in about 60 seconds. Here we are talking about group working. So this is a slightly different idea. I'll explain this once this is done. So your time starts now. 60 seconds. Very good, Tarun and Akshat. Let's take a look at what is happening here. So here the logic is, when we are dealing with, see, till now we have seen questions where individual people A, B, C or Ram, Sham, etc. were given. So when you're dealing with individuals, we take the efficiencies different. So we take efficiency of A, efficiency of B. They are all going to be different unless and until they mention in the question that the efficiencies are same. But when we are dealing with group, when you're dealing with 12 workers and this kind of questions, we will take efficiency of everyone belonging to this group to be same. For example, if I say 15 men and 6 children are working, I will take all the men to have same efficiency and the children to have a different but same efficiency. So if man's efficiency is M, the child's efficiency will be C. They may not be equal, M and C, but all of these children will have the same efficiency. All of these 15 men will have the same efficiency. That is the logic we use here. The second thing is, we use the concept of man, day, hours by work. So the number of men into the number of days into efficiency of each man divided by the work. This should always be a constant. In fact, there could be number of hours per day also. So this should always be a constant, whoever is working. This is the concept we're going to use. So how do I use this concept? The concept is, take the first case, 12 workers. So 12 into, number of days is 25. Efficiency we don't know, let's call it as H. Number of hours is not being mentioned in the question, so don't use it. Then don't write it. Divided by quantity of work is W. We don't know what is W, it is just W. In the first case, should be equal to, now the second scenario, write the same expression for the second scenario. 15 people working for how many days? X number of days. We don't know what, that's what we need to calculate. Efficiency is the same because remember, same workers. So the efficiency is the same here. But is the work same? No. The work is thrice as big. So 3 times W. This is how you form your equation. And your W gets cancelled, then E will also get cancelled, and you will get 3 5s are, 5 goes 5 times, so 12 5s are 60 gives your answer as option B. So the whole idea here is man day efficiency hour by work is a constant. Okay, so this is the concept, this is how you use. Now this question can also talk about men and women finishing a work, which means if I say 10 men and 5 women can finish one work in 20 days. What it means? It means 10 men, efficiency of each man is EM, into the time taken is, let's say, 20 days. Plus, these are not the only people working, right? You have men. This is the quantity of, this is the work done by men, plus women, 5. Efficiency of women is EW into, again, the same 20 days, divided by the total work done. This should be constant. So this is how I form my equation. So I can give you a question where I say, 10 men and 5 women can finish a work in 20 days. The same work will be done by 5 men and 15 women in 25 days. So I can write this right hand side as 5 men and 15 days, or rather 25 days. 5 men, 25 days and 15 women. And I'll get some relation between my efficiency of man and women. and based on that the question will progress forward. So this is the whole idea. Man day work by man day hours and efficiency by work should be equal to constant. Okay, so let's take one more question. Okay, so this is a time and distance now, so we're slowly moving on to time and distance. In fact, let me see if I have any time and work. Okay, all these are time and distance only, that's not a problem. Let's move on to time and distance. Let's solve this question. I'm going to give you once again this is about 60 seconds. It's a very simple question. Try doing this in 60 seconds. Your time starts now. Alright, so that's your time. What's the answer? So whole idea is very simple here. The distance is always speed into time. The distance covered is time taken into the speed at which you are traveling. On walking at 3/5 is usual speed. So let's say the usual speed is s, the usual time is t, which means the distance becomes d. So let us say this is the normal case. Now the distance is remaining the same, but the speed becomes 3/5, so 3s by 5, and the time becomes 3 hours more. Takes 3 hours to reach. Okay, so this is 3. On walking 3/5 of his usual speed, Krishna takes 3 hours to reach home from his office. So time taken is 3 hours. So you divide these two, your d gets cancelled, your s gets cancelled. So what do you get? You get 1 equal to 5 by 3 into t by 3. So your t should be 9 by 5 hours. Remember, the time is in hours. So find the time taken when he is walking at his usual speed. So this is your usual speed, 9 by 5 hours. But convert this into minutes. 9 by 5 into 60. So 5 goes 12 times. So this is 90 plus 12, 18. So 108 minutes. 108 minutes is option A. Okay. So once again, time and distance, we will use the same. The whole idea for time and distance is speed into time, or your speed is distance by time. Remember, time and distance and time and work are very similar in nature. Here speed is distance by time. In time and work, efficiency is work done by time. They are very, very similar concepts. So your speed is kind of, see, speed ultimately is the efficiency at which you are traveling, rate of travel. The time taken for you, or rather the distance covered in a given time is called as your speed. The work done in given amount of time is called as efficiency. They are not really different concepts. If you understand one, you should be able to understand the other also very similarly. Okay, so let's go ahead and take a look at one more question. Here is the next question now. Try to do this in about 90 seconds, 1.5 minutes. Your time starts now. Alright guys, so that's 90 seconds. Muskan, Vanshika, Akshat, Tarun, none of you have got the correct answers. Are you guys there? Can I have a quick round of responses? Are you all there guys? This is not a difficult question, you should have got the answer. See, let's understand what is happening here. See, if I am traveling at 12 kilometers per hour, I take 20 minutes, I'm 20 minutes late. If I'm traveling at 18, I am 10 minutes early. So neither of the speeds are correct. I should reach on time. Okay, I should reach on time. So let us say my correct speed is S and the correct time taken is time T. This many minutes I should take to reach. If I am going at speed S, which is the correct time, I am reaching on time, my time taken is T. T minutes to reach, right? Now, what is happening? My speed is 12. So the distance is same. So distance is speed into time. My correct time into the correct speed. But the same distance D is given to me as 12 into now 20 minutes late, which means I'm taking 20 minutes extra. So T plus 20. Similarly, my D should be equal to 18 into, now I'm reaching 10 minutes early, so 10 minutes less time I'm traveling. So T minus 10. They are both equal because the distances are same. So divide them. So 6 2s are 6 3s are. So you get 3 by 2 equal to T plus 20 by T minus 10. Cross multiply and you get your T. So 3T minus 30 equal to 2T plus 40. So this gives you T equal to 70 minutes. Your T is 70 minutes. What are they asking? Find the distance if it is same in both the cases. So what is my, so if I take my T, my distance I can use any one of the two equations. So I'll use my distance is 12 into T plus 20. But remember, this is in kilometers per hour. This is in minutes. Because 20 is minutes. So which means my time is in minutes. I have to convert only, I can only calculate the distance if I convert it into hours. So my distance is 12 into 70 plus 20 is 90 minutes. 90 minutes is 1.5 hours. So please don't forget to convert. See, if you notice, I just took T plus 20 and T minus 10. And it doesn't matter whether I convert it or not. Because I'll get the answer in minutes. Whether I convert everything into minutes or whether I convert it into hours, it doesn't really matter. I will get my time. See, if I convert it into hours, I'll get directly in terms of hours. But I don't have to waste my time. I'll find my minutes, then add my 20 to it. Then I'll convert here. So here I'll get 12 into 1.5, which is 18. 12 plus 6, which is 18. So the answer is option B, 18 kilometers. Okay, so this kind of question you should be able to do in about 90 seconds, guys. So you somehow missed it. Let's go ahead, don't worry. Let's take one or two more questions before we wind up the session. This is the next question. Try to do this in another 90 seconds. Your time starts now. Okay guys, that's 90 seconds. This is the last question here. So let's understand the idea behind the question. They're asking something called as average speed. So the idea of average speed. So what is your average speed? The average speed is total distance traveled divided by total time taken for the entire journey. Okay, so the total distance traveled by total time taken. Many of the students make the mistakes of taking average as average 1 plus average 2 plus average 3 by 3. So if there are 3 averages given to you, you can't take averages or rather average of averages to get your final average. Always average is total distance by total time. Anyway, so how do we do this? What is the total distance traveled? So let us say the total distance is D. Or rather, I'll take it as 3D. Now, why do I take it as 3D? Because 1/3, 1/3, 1/3 is easy for me to divide. I can also take it as D and D by 3. But if I take it as 3D, then the 3 parts of the journey will be D, D and D. These are the 3 parts of the journey, right? So, total average speed is total distance. Total distance is 3D by. Now, the first part of the journey, what is the time taken here? Time taken is distance by speed. In the first part of the journey, he is traveling at a speed of 18. So, D by 18. So, this is my time. Plus, second part of the journey, it is D by 24. So, D by 24. And similarly, the third part of the journey, D by 36. That is the time taken. So, D by 36. Now, you take the LCM here. The D anyway gets cancelled. So, you get the LCM. What is the LCM? 18, 24. So, 6 into 3 is 18, 6 into 4 is 24, 6 into 6 is 36. So 6 into, I think 3, 4, 6, the LCM here is 12, which is 72. So 72 is the LCM. So 3 by 72, 18 goes 4 times, I think 48 was a 32, yes. 4 plus 24 goes 3 times, plus 36 goes 2 times. So your answer will become 3 into 72 by 4 plus 3, 7, 7 plus 2, 9. So 9 goes 8, 8 3s are 24. So 24 kilometers per hour, option A is your correct answer. So remember here, the whole idea is average speed for the entire journey, if it is done in parts, is total distance by time taken, total distance by total time taken, which is nothing but sum of individual times. Each part, what is the time taken? So that's the whole idea here. Alright, so friends, I hope you enjoyed this session. I have a lot more of these things coming up. So today we have taken up basic ratio and time and work, time and distance. We will continue with time and distance in the next maths class, and we'll take up 1 or 2 more very good areas of arithmetic, which is quite important for your CUET examination, as far as the maths section is concerned. So I'll see you in the next one. All the best.